Let's start with some problems on forces in three dimensions. So first problem, let us see three forces are each of magnitude p equal to p, means each of magnitude p acts on a body, one at this point parallel to y-axis, another at this point. This is 0 b 0, 0 b 0. This is a 0 0 parallel to z-axis, and one at 0 0 c parallel to x-axis. Okay, so these are the three forces. So our system here is comprising of three forces, each of magnitude p, and working at three different points obviously, and parallel to three different axes. Okay, so we are having three forces each of equal magnitude. Now we need to find out so that the central axis passes through the point this one. Okay, and its direction ratios will be this one. The central axis, whatever the line of the central axis will be, it will be having this direction ratio. Okay, so let us have a look at how to do it. Okay, so this is the figure corresponding to the problem as we are provided with. We are just drawing the forces. See, at a00, at 00c there is a force. Okay, so I call this point say t3. Okay, so there is a force p parallel to x-axis. So for instance, if you want to match with the problem, you see 00c, at this point there is one force parallel to x-axis, right? So this is the thing, parallel to x-axis. Again at 0 there is a force parallel to z-axis, and at a00 there is a force parallel to y-axis. So we have just drawn the forces. Okay, so this completes the system, and just whatever we have drawn, we are just writing it out here. And now what we know, whenever we are dealing with a system, it is ultimately reduced to a single force and a couple of some moment. Okay, element. So this R is the single resultant force, resultant of our system of forces. So what are the x, y and z components? This is the component along x-axis, along y-axis, along z-axis. This is nothing but, you see from the figure itself, out of all these forces, this is only parallel to x-axis. This force, okay, is not parallel to x-axis, it is perpendicular to x-axis, so it will have zero component along x-axis. This is also having the same thing. It is perpendicular to x-axis because it is parallel to z-axis, so it will also will not have any component along x-axis. So along x-axis we are only having one force, so it will be x equals to p plus 0 plus 0. Likewise for y and z. Okay, so this only we have written down. Achha, why we are all of a sudden trying to find out x, y, z? Because you see the question, our main motive is to find out the central axis first. Once we find out the central axis, then only using that equation you can find out that yes, the central axis is indeed passing through this point. And as soon as we find out the equation of the central axis, from here only we can find out the direction ratio. So as we are in search of a central axis, we are going to apply the formula for the equation of this line of the central axis, and that formula demands you to find out this xyz, that is the resultance component along x-axis, y-axis, z-axis, and also the moments of the couple along x-axis, y-axis and z-axis. There is LMN also we need to find out. So we will next find out LMN. So G be the moment of the couple of the entire system of forces. So actually it is nothing but the resultant of the couple, resultant of the moment of the first force, resultant of the moment of the second force, resultant of the moment of the third force. So you just simply using how we find out the moment of a force with respect to an axis, with respect to a point, we are finding it out because we are finding it out with respect to the base point origin. This one. This point we are using as our origin. So we are finding out the moment of this force with respect to origin, moment of this force, moment of this force, and the moment, all these three moments add up to find out the moment of the couple L, A and N. Okay. So that is what we are doing here. So once we do this thing, okay, for example, just for instance, let me just explain once. For this, how it is coming. At the point A00, which force is acting? Let us see. At the point A00, this is the force acting. It is parallel to y-axis. That means it is component P along y-axis, whereas it is no component along x-axis and also no component along z-axis, right? So that means we will be having 0p0 as the force. Okay, this force I can write as 0p0. Okay, this force I can write as 0p0, and its point of application is this t1. That means it is a00. That means if we want to find out now the moment of this particular force, then it will be like this, R cross F. Remember the formula, it is R cross F. It's the moment of the force, how we find it out. Okay. So that is the thing which is we have done. Likewise for the other two forces. And we just simply add out all the moments of the forces. So you get this thing. If you add it out and you just perform this cross product thing, you will get this thing here. Whatever we have written down here. Okay. So you can easily equate out to find out L, M, N. Okay. That we need. That is here written. Okay. So once you find out, now what you need to do, you find out the pitch, okay, which is nothing but G dot R by mod R square. So this is G dot R means G is element and R is XYZ. So simply you are going to get this thing, and mod R square obviously is this thing because R equals to XYZ. Okay. So simply we are finding it out, putting all the values because we have collected X, Y, Z, L, M, N. Okay. So we are just now plugging in all the known values we have calculated so far. Okay, so we are just putting all the things together. So equation of the central axis ultimately becomes the equation of the central axis. G equals to, if you memorize back, it is equals to G equals to R cross R cross R plus PR. So P you have to find it out here. You have plugged it in here. R is a PPP along 3 XYZ directions, and R cross R means R is what? R is any point you are taking on the central axis. If it is your central axis, then you are taking any point, say P, or if you don't want to confuse with this P, so let me put Q, any point. So this is a running variable XYZ. So here I put XYZ for this R, and again capital R, that means the resultant force are having three components, so we have put it all together and we just perform it and find it out. Okay, so as soon as you find it out, you can equate out the component L equals to M equals to and N equals to. That's what we have done here from this here. Okay, so just you can just simplify it. There is nothing to explain here. A bit of calculations you have to perform very carefully so that you find out these three equations. So we have marked this system as 2. Okay. Achha. So Q be any point on the central axis. So if Q is any point x dash, y dash, z dash on the central axis, then you just plug it in here in place of x, y, z. Okay. So once you put everything together, you are getting the equation of the central axis as this one. Okay. So if you are getting the equation of the central axis on this one, what is your DCS of the line? From here you can easily find out what is the DCS. These are the direction ratios, right? If you just memorize back from your whatever geometrical idea, you have x minus a by small a, say y minus b by small b, z minus c by small a capital C, or whatever. So say small c, whatever you just, it's the symbol, nothing else here. So these are the direction ratios. The direction cosines are given by a by root over of a square plus b square plus c square. Okay, so here it is p by 1 is everywhere. So p by root over of p square plus p square plus p square, that means 3p square. So 1 by root 3 you are getting. Okay, so this is how we have calculated the direction ratios. Comes out to be this 1 by root 3. This is the direction cosine, so direction ratios will be 1 1 1. You can easily see it. So these are the direction cosines and direction ratio part done. Now what is we are supposed to prove here? We are supposed to prove that this line is passing through the given point. Okay, what is the given point? That means this point. This point. We have to somehow prove that your central axis is passing through this point. Right. So that is a bit of we need to select the any two equations and equating it. We can easily find out that this point is indeed lying on the central axis. So what we are doing here, you are getting three ratios, actually four ratios, 1, 2, 3, 4. This 3 and 1 for the pitch. So you are considering first and last ratio. If you consider this one and this one. So from there, just simply find it, just simplify it so as to just what I am doing. I am taking the first one, equating it to a plus b plus c by 3. Then you are just simplifying it. And once you are simplifying it, what actually you are doing, what is the trick I am doing here, y dash plus this thing you are getting from the equation itself. With it I am adding and subtracting this quantity. Now how do I suppose to know what quantity you are adding or we need to add or subtract? Just look at the equation, look at the point which you need to bring or which you need to show to be lying on the central axis. Okay, just look at the point. This is the point. Okay, so what is the component of y for this point? Minus 1 by 3 b plus 2c plus 3. Okay, So this is the thing. Let me see, minus b plus 2c plus 3a. Yeah, see. So this quantity I am adding once and then subtracting it because it remains unchanged. But once you do it, what is the thing you are getting? If you to just keep this thing with here, I am keeping. I added this and subtracted it. So my entire equation remains unchanged. But as soon as I do it, I couple these two together. I couple these two together here, keep it as it is, and simplify these two terms. Soon as you simplify these two terms, you can easily see you are getting this quantity and this quantity you bring on this side. Just like this. And then simplify this with this b term and this term. If you simplify, you will get this term. So see, this is nothing but minus of minus 3c plus 2a plus 3b. And this is minus of minus b plus 2c plus 3a by 3. Okay, this let me put simply because this minus is as a whole. So this is again the z component of this given point, that is the point we are supposed to bring, or we are supposed to show lying on the central axis. See this point. Okay, this one. So this is done. We have proved that this line is passing through a point which has y-axis, which has y component this one, z component this one. For that we consider the first and the last ratio. Similarly, you can consider first, second and the fourth ratio. That means one involving the x thing. That means here we did it considering this one and this one. So for x you can consider this one and this one. That means here there was no x. So there was y dash and z dash. We have obtained y dash and z dash value. To obtain x dash value, you consider either this third ratio, fourth ratio, or second ratio, fourth ratio, because both of them is involving x dash. And again you apply the same trick. Whichever you want to find the point, you just add and subtract the same quantity on any of this side, either with the y dash part. See, one thing, I could have done the same thing on this z part also. On this z part also I could have done this thing here. Okay, then you have to add and subtract the z component of the point. Okay, and then do the remaining thing in the y dash component as we did for the z dash thing. Okay, so any one you can do here. Similarly for the x also, I hope you can understand what you need to do. Okay, so this proves that our central axis is passing through the given point. So this completes the problem. Okay, so the next one. Okay, this thing is done, DC is done, direction ratio is done. Then what is this remaining? Second problem. Okay, so this one, forces x, y, z act respectively along the lines y equals to 0, z equals to 1, z equals to 0, x equals to 1, and x equals to 0, y equals to 1. Prove that the pitch of the equivalent range is this thing. Range means again what is happening? Your resultant force and the axis of the couple are coinciding. Okay, and you are getting the central axis. Okay, points are central axis. This is the main fundamental thing. So again we are drawing the figure as far as the problem. So what we are provided with, you are saying x is acting along the lines y equal to 0, z equals to 1. So y equals to 0, z equals to 1. So this is z equals to 1 and y is 0 on this line. So this is your x force. Okay, so 0, 0, 1 this point. Okay, again z equals to 0, x equals to 1 for this point. Z equals to 0 means, and x equals to 1, because x equals to 1 means it is on the x axis. You can see from here z equals to 0, and also here y will also be 0. Okay, this point. And last one, z acting on at the point x equals to 0, y equals to 1. So it is definitely on the y axis here, y1, and x equals to 0. So this is the thing, it is a z axis. Now one thing you might just think, I am taking this point. Okay, so how we are sure these are the 3 points? That means I said y equals to 0, z equals to 1, but I didn't say anything about x, right? But from the 3D geometry theory already you know y equals to 0, z equals to 1, that means x is unrestricted. X can have any value, right? X can be from minus infinity to plus infinity. So that means it can be, let me draw this figure irrespective of whatever I have drawn till now. Let me draw the axis and let me concentrate on just on this line. So y equal, let me put this whatever reference frames or axis I have set in here. Okay, so y equal to 0, z equals to 1, right? So one thing is clear, z is 1. So it can be z equals to 1, say suppose this is the point 0, 0, 1. So this line is z equals to 1. Okay. And y equals to 0. That means definitely you cannot go on any of this portion, because if you try to take any line here, then here y not equal to 0. Okay. Or on that side also, if you want to take extend there also, that will also not do, because y is non-zero there. Okay. So if you want to take y 0, then I can extend like this along this. Z is fixed up to this height I have chosen here, and then x is unrestricted. Okay, so this is actually my line of action of x. Capital X, that is the capital X means the force here I am saying. Please do not confuse with this x. This is the, you may use a small symbol also to to symbolize the reference axis. Okay, and this is your component of force. These are different. Okay. So this is your line of action of force. Okay. Now for our simplicity, because you just recall back, if you need to find out the range, you need to find out the central axis. That means you need to find out the moment of the couple, and once you want to compute the moment of the couple, you need the point of application of the force. So the more complicated point of application you take, your calculations become complicated. Okay, but if you can take any point on this line as a point of application, because the force is acting along this line. This is a point of application, this is a point of application. Any line or any point on this line is a point of application. Then why did I choose this thing? Because here the component is x equals to 0. So that means our point of application now is 0, 0, 1. Anybody could have taken the point of application, say for example 5, 0, 1 also. But then you can easily understand, when I try to compute the moment of this force, I have to take r cross f. Okay, that means r cross x 0, 0. That means this r will now be 5, 0, 1. So that means in this calculation of this cross product, I need to carry on with 5, 0, 1 and x 0, 0. You can do it, no problem, but that will be a more bit complicated. Ultimately, you will see all this will balance each other inside, and you will get this restrict thing. There is no problem with it. You may try also as a homework problem to take any other point other than the 0, 0, 1 or this 0, 1, 0 or this 1, 0, 0. You will get ultimately the same result. So these are the thing we are taking here, this point and this point, for these three forces given here. Now the same logic we followed for the previous sum, we are doing it here also. X axis, y axis, z axis, we have just plotted it in here, we have written it for explanation part, and then you need to find out what the resultant force, this xyz, and the couple of the force system is the resultant couple, means nothing but the summing of the moments of each of the forces. So as I said, I have used these points as points of applications and corresponding forces. So this will be equals to this, coming after you calculate, easy calculation, this is zxy. So L equals to z, m equals to x, n equals to y. Okay, so I have computed element what I need. I already know xyz, because xyz is given in this symbols only, capital X, capital Y, capital Z. So pitch of the range, because I need to find out the pitch of the range, which is g dot r by mod r square. This is the formula, again I applied it. Okay, you could have find out this dname also, r comma pr, that also you can find out. And ultimately what your question was to find out the pitch of the range. The pitch of the range, if you just simplify, you are getting this as your expression. So this one, see, this is your ultimately the pitch of the range which was asked for. This is the pitch of the range P. So this completes the problem. Even if this question is added on with it to find out the d name, then also you can easily find out this thing. And also you can understand and find out the equation of the points of central axis also, because I have all the components or the ingredients to find it out. Okay. Now let us move on to the next sum. Okay, so OA, OB, OC are three coterminous edges. Coterminous means we having the same point as one of the terminal point. Okay, O is the same fixed point here. OA, OB, OC all are emerging from the point O. So coterminous edges of a cube. You can easily understand for a cube, not all the edges are coterminous. Three edges I can take from a point, or can emerge from a point. So any of these three edges I have taken passing through a common point, this O. So these are the figure if you want to see OA, OB and OC. These are the three coterminous edges along which actually these three coterminous edges and A dashed. A dashed is what? A dash is nothing but the diagonal. You see, A dashed is nothing but the diagonal here. Okay. So along these three things, A dash, acha, A dash, BB dash, CC dash, O dash, whatever the diagonals you are taking. Okay. Then you are doing what? Along BC dash, CA dash, AB dash and O dash act forces X, Y, Z and R. Now let us see one by one. BC dash. What is BC dash here? Let me draw this or find this out. This BC dash means BC dashed. Okay. So this is your force X. As you can easily see, I have drawn the cube so that X axis, Y axis, Z axis are three edges of the cube. You see. And this BC dash is nothing but parallel to the X axis. Right. BC dash here is parallel to the X axis. Okay. This is your X. Capital X is your force here. And then what? This is done CA dash. What is CA dash? CA dash, let me see, CA dash, this. This is along Y axis. So this is capital Y. They are taking, don't get confused. They are, as it is parallel to Y axis, that's why I am taking capital Y. It could have been any other symbol. There is nothing to do with the symbol here. Whatever symbol they put in your problem, you have to carry on with it. But don't get confused or get the wrong idea that only because it is parallel to Y axis I am taking capital Y. No, I could have taken say A, B, C also. A along X axis, B along Y axis, C along Z axis, and R along say R or D along other line. Let me see what is the line they are pointing it out here. So up to X, Y and Z. Z for Z, AB dashed. AB dashed, let me search in the figure, AB dashed, this is AB dashed. This is parallel to Z axis. And O dashed, corresponding to O dashed, X R. Okay, so O dash is the diagonal as I said before. This is O dash. You can easily understand or imagine as a three-dimensional figure, cube. So this O dash is a diagonal. Okay, so along it acts the resultant R. One thing let me point out here, though they have not shown it in the figure, but in your problem you have to show it. Okay, otherwise marks will be deducted. Okay, you have to show all the forces. Whatever problem, according to that you are drawing the figure must be complete. Okay, the figure individually fetches some marks. If your figure is wrong, your marks will be deducted. Okay, so I need to show this R also here as I have shown X, Y, Z. Okay, so taking O as the origin axis along OB, OC. So, let me say one thing here. Here it was given about a cube and some forces acting along some sides of the cube. Never they said about anything about the reference system, reference axis. But what we are choosing here, as we already discussed in the lecture, whenever we have just going through the theory of this force in three dimensions, we said we have to fix a base point, we have to fix a reference system with respect to which we will measure everything. Okay, so for here, as per the problem is given, we have the idea that once we take this O as the origin, okay, and once we draw a cube having X, Y, Z as three edges, then it will be easier for us to deal the problem. Okay, but that is not mandatory. I am repeating here, that is not mandatory. You could have taken any other point as your origin. So supposedly you could have taken like this also. Say suppose, where do I show it here? Let me show, we'll remove it. This as say your O dashed as the origin and this as your cube. No harm in that also. You can take. Then you take this as O and this as OA, OB, OC and this as O dashed. I am using O dash. Let me use double prime. So O double dash is your origin. And this is your Y axis, this is your X axis, this is your Z axis. You could have taken. But you can easily understand once I take this, then every point here where the points or the forces are applied on, I have to find out the coordinates of all those points with respect to the reference system you are fixing. And you can easily understand that will be a hectic job to do. Okay. And then all these coordinates again will be used to find out or rather compute the moment of all these forces. Okay, that will be a better complicated one. So to make the system, and we know ki it doesn't matter whichever origin or whichever reference system you are taking on to compute. So why should we take all these complications with us for computing? So we just choose the easiest way and we have fixed this as the origin, because once you are measuring all these things, one thing we have to satisfy. whatever base system you are applying, that should not change with your calculations, right? That means once you're calculating one force, you are taking this as origin. For calculation of another force, you are taking some other, you need to take some other point as origin. If that is the case, then we need to be careful. But here the cube is not moving, it's fixed, okay, right? So we need to take care only of the geometry of the cube, no motion of the cube. So once that is fixed, so then why not take this as the point of these three edges as the origin, and along the three and these three edges and the three perpendicular axes, because also we have the idea that the three edges, any three edges, coterminous edges, if you take up a cube, they are perpendicular to each other. And the reference system also, there, a 3D reference system, there are three perpendicular lines. So we can easily combine those two. So we have done it here. And I'm just putting all these three things here. And once you put all these three things here, just you get the lines of action of the forces as we have done before. The point of applications x at this for x, what is the point of application? 0, a1, 0. Okay, so this is the point of application of for x, y, z. For what was x? This point. So this point is on the y axis, and as I said, any point you could have taken along the y axis. So along y axis here, y is non-zero, so some fixed point you are taking. Acha, from where we are getting this idea of a? Because here okay, we are taking the length of the cube as a, any side of the length of the cube as a, small a. Okay, so that wise this point b point becomes what? 0, a0. This point becomes a0, 0. c becomes 0, 0, a, 0, 0, a. And this point will become a by root 3, a by root 3, a by root 3. Okay, so these are the points you are using, the line of action. This one, that is the lines they are showing, x minus 0 by 1, because along x axis you are taking y minus a and z minus x minus because parallel to x axis, so 1, and parallel to x axis means perpendicular to y axis, so 0, perpendicular to z axis, so 0. This actually we need not go through, you already have the idea of 3D geometry, even then I'm just recapping as you may say. So this is the thing you are getting, okay, for x, similarly for y and z, and for r, all these three 0, 0, 0 you are getting, y 0, 0, 0 you are taking because it is passing through the origin, this r is passing through the origin, so let this be the point of application. This is the simplest one we can take, so I am taking that. You could have taken a by root 3, a by root 3, a by root 3 also, but you have to again use it for the moment calculation, which will be a bit complicated. So I am taking 0, 0, 0 because I have this, any point on this r you can take as a point of application, right? So this thing I am taking. So when these things are done for x, y, z, you need to calculate L dash, M dash, N dash. So what is x dash, y dash, z dash? 3. All the components of the forces now you need to add up. Okay. So along x axis, what are the forces you are having? From here you are having, and from here also you are having. See. So x dash equal to x plus r by root 3. Okay. Y dash equals to y plus r by root 3. Z dash equal to z plus r by root 3. From here only you can see. See, from here this is the component along x axis, this is the component along y axis, this is the component along z axis. So from here you are getting r by root 3. Okay. Okay. So this is the thing we have calculated. Again, L dash, M dash, N dash we need to calculate. Simply moment of the resultant of the four forces here, for force x, for force y, for z, for r. So this thing, so L dash also, M dash, N dash you are getting. So the system reduces single force, they are saying. See, let us read the question, complete the question. Show that they are equivalent to a single resultant if this condition holds. This is what we are supposed to prove. Okay. So if we are reduced to a single resultant, recall back the theory, any system of forces is reduced to a resultant and a couple. Now for this sum they are saying it will be only a single resultant. That means there will be no couple. Once you can show this condition is satisfied. Okay. So that means what we need to prove? We need to prove the couple is non-existent here. That is, it is 0. We need to prove that only here. So that will lead us to a single resultant force. So that means this thing, if the system, if your system is reduced to single resultant, that means suppose this resultant, let me call r dashed. Usually we have r dash and a couple of moment d dash, say. Now they are saying there will be no g dash. If there is no g dash, then g dash dot r dash is 0. Okay. So g dash dot r dash is again what? L dash x dash plus m dash y dash plus n dash z dash. That will be 0. So this is the condition. So once you put this as a condition, you just plug in all this L dash m dash n dash, all this x dash y dash z dash we have calculated, and you simplify it to find out that indeed you are getting the condition they have written above. Okay. So this completes the proof. And the last one, this also you can do on your own, just for the hint I may supply, and the entire sum obviously is done here. The two forces P and Q act along the straight lines. These are the straight lines which is given. Show that the central axis lie on this straight line. Again the same thing, you need to find out, you need to draw the figure as per this thing. So these are the points. So one thing you see here, if this is the line y equals to x tan alpha, z equals to c, then what you can say about y equals to x tan alpha? Y equals to x tan alpha. That means y sin alpha by cos alpha. So x sin alpha by cos alpha. So this, that means y minus 0, x minus 0, and z equals to c. So z minus c equals to 0. That means z minus 0 equals to 0. That means I can put all these two things together. So this is your line of action of this force. Okay. Line of action of this force.